Just Checkity check. 1 1 2. Checkity check. All right, guys, we're going to get started here momentarily with the presentation. The way this is going to work, we will call you up here, bring you into the green room here. We'll get you a Zoom link, get you set up on Zoom. You'll be able to present up on the big screen, and we'll have you up on stage going through kind of what you did. And we'll be calling you up here in just a few minutes. All right. We're going to get started with the first folks that are going to present today will be the Battle Line Project. So if you guys will come up here, we'll get you set in the green room and get you ready to go.
an organization just for ease of demonstration purposes. So start out, if you enter a user that's not, or input that isn't, oh, sorry. If you enter input that is incorrect, it'll just show you a little error message, but put in an email for a valid user, and go ahead. Sorry, I'm having trouble typing, holding the mic. We'll go ahead.
And that error message is from IDEP, right?
Yes. So what's happening, actually, I'm going to enter that incorrectly. Did we start with the ENV? Or so what's happening behind the scenes here? Thank you. Let me get this. What's happening behind the scenes here is when we enter a valid user email and password, we are sending a, we are authenticating the user and getting a bearer token back, from which we are going and making a call to Provides API, or the ident API, which returns back a bearer token for an organization, which we then pass in to a vault and create a vault. Is this still not working?
No. You want to go grab your computer?
Yeah, I'll go ahead and do that.
Take over. The wonderful...
We should remind you that working is not one of the criteria for the judging.
Well, happily we tick that box. So, we're going to have Ian go and set this up on his computer. The entire build environment was on his machine, so it's kind of my fault. But as he was kind of talking about, we have integrated Ident, which is the identity management system that Provide enables, and we've also integrated the Vault microservice. And we were looking at trying to integrate Endchain and the privacy microservices. We spent a good amount of time attempting to do that, and unfortunately, in the amount of time we had, we weren't able to completely accomplish that. But as we'll kind of get into in a moment, we made a lot of great strides in setting up that code base, and we're really looking forward to kind of building on that and getting it to maturity as time goes on. So I guess while we wait for Ian to set that up, I will really quickly just run the smart contract tests, which are very light. I wrote these in the past hour, so nothing incredibly interesting, but yeah, we're recovering. And okay. So to accomplish this, we essentially added to the examples repository or folder within the baseline repository a battle line right here, a battle line folder. We also we go to the GitHub. Oh, it's gonna be one of these. We opened a PR. I'll open that when Ian's back on, so we're not wasting time. But what we've done, because we're trying to construct this full stack application that a lot of people who are native to Web3 development are going to be familiar with, whether that's working with something like Hard Hat to actually spin up the contracts, or a subgraph to provide the data indexing. We wanted to include that to, again, try to make people who are familiar with these services kind of feel more at home with the baseline stack. So again, if we go into baseline, please go into baseline. Battle line.
Could you give us some context on what problem in the battleship structure that is being, where you're using baselining to solve? I mean, what is the?
Yeah. Battleship is one of the best examples of kind of example where you've got two parties who neither of them want to share their information, but they need to be synchronizing on certain parts of the state in order to establish consensus. So you can kind of think about if you've never played Battleship before, essentially all you do is you pick a couple of ships of varying sizes and put it down on a grid, and then you and your opponent take turns guessing which grid you're trying to hit. And what can happen, John, I love this analogy, your 8-year-old daughter, right? She is unable to either completely understand the rules or maybe she just feels like cheating today. But you have to kind of keep her in check. But by doing that, you've now ruined the game for yourself. You've exposed the information. So what we're trying to do is provide a zero knowledge way to kind of referee the rules of Battleship. And because it's a really simple application, once you've kind of understood how to integrate it with something like Battleship, extrapolating it to something more complex, more actual business logic will be a lot more clear, is kind of what we're trying to establish. So, ready? Okay, yeah. So I think we should actually get to show that off now. Let me stop sharing my screen real quick. Please, there we go.
Okay, perfect. Alrighty, thank you for being patient with the technical difficulties. So this is the UI we came up with. So did you already run through what was going on behind the scenes? Okay. All right, so yeah, we'll go ahead and try this again now. So we're going to go ahead and enter a valid user email address, which will associate a user with a existing organization, which is then associated with the vault, from which we generate a, explain this part better.
There's the reference token, or not the bearer tokens, and I think that's generally what you're referring to, right? We want to go to idents and pull out the identifying or authorizing tokens so that we can then go engage with the other microservices. So yeah, we've got it right here. Do you want to show it off a little more?
Yeah, absolutely. So unfortunately, we didn't get to the point we wanted to where we could actually integrate some of the back-end work, but basically on this UI, we set it up simply so you could have one ship, however many squares horizontally. You click one dot in the second, select the ship. Once you have a ship placed, you can go ahead, enter coordinates from a simple drop-down menu. And if things were integrated the way we'd want, you'd go ahead and launch, and you would receive feedback looking at the, or based off where you hit on the other user's board. And through zero knowledge, you'd be able to confirm whether or not you got a hit without knowing any information about their board whatsoever. So the UI, we got pretty far with this, and hopefully, as we continue to work on this the coming weeks, we'll be able to get a full demo here wrapped up shortly, fully functional.
Yes, yeah.
So on the privacy service, it seemed like you guys were pretty close. I even think you had some working API calls. How much more effort do you think it will be from where you left things off to actually making use of that service?
So we were able to establish a prover, and we were talking with a couple of people today and actually established that maybe we don't need to be integrating Nchain in order to actually integrate with the privacy microservice. Yesterday, we were under the impression that we needed to be like enrolling the the privacy microservice with different permissions that came from the rest of Provide. That might come from users, but coming from an actual. Yeah, for sure. And then I guess if we're on that note, one other thing was we definitely kind of struggled a little bit with trying to exactly figure out which of the predefined circuits were best for our application. So Yeah.
Sorry about that. I think that you also ran into an issue with the docks.
Yeah, yeah. That was a really small thing. I think there was a curve that was labeled like BN 256 and it was like 254.
Right.
So I'm sure there's a couple of other things peppered in. I think like the JavaScript provide.js is labeled as Java. So
Weird.
I think there are a couple of gimmies in there that can be fixed up and really quickly improve the readability of a lot of the stuff.
Great.
So I guess to a little more expound on the zero knowledge proofs really quickly. I think we'll probably we won't keep it going too much longer, but we'll talk a little more about how we integrated the zero knowledge proofs or how we're setting it up at least as we move forward, and we'll briefly talk about the subgraph as we kind of want to have that data indexing service as migration to base ledger is kind of prioritized. So here, do you want to disconnect?
Yeah, sure.
Yeah, I think we definitely need to wrap it up, but I really applaud the work here. It's good.
Okay, well then I will leave it with this. We did raise a PR on the baseline repository, basically talking about everything that we've done so far, as well as everything that we want to do moving forward to get this to, again, a state that could be considered complete and something that a developer could look at, play around with for a couple of days and come out really understanding the stack. So,
Great job.
thank you.
Who's up next? I'm in a weird mood today.
All right, donor-based project, where you guys at? You guys are up next. Are y'all ready? All right.
I mean, yeah.
We will pop on over into the green room over here.
Yeah.
Kyle, that's not necessary. That's
I don't,
unnecessary.
I'm not sure what's going to come out of my mouth today.
Zach will get you set up right over there in the green room, and then we'll be out here ready to present.
Woo, yeah.
We got a fan.
So here we go. I'll just put this.
All right. Are we live? I don't.
Yes. All right. Just in case, stuff, kind of keyword. Yes.
Okay.
So that if you want to put any words yourself.
Okay. All right. Thank you guys. I'm really excited to be here. This is like one of the first in-person hackathons since post-COVID. Oh, let me get the mic. I just want to introduce our team. So my name is Shadman Hussain. I work at CGI, so government consulting, enterprise blockchain, but that's my day job. At night, I become an enterprise degen. I like to coin the term as of this hackathon. So doing all kinds of DeFi-related things. So I'm trying to merge the both worlds of enterprise and this creative degenerate side of this crypto web, Web 3.0. So I feel like I live two lives, but
Degen.
enterprise degen. That's right.
TM.
Trademark. I want to introduce my friend Olu. We've been working together for a few years now. If you want to introduce yourself.
Sure. My name is Olu Akinwande. I'm a blockchain developer, but also I run a dev shop. I'm the CTO of a corporation called Montech, and we're in collaboration all together with MPA, and we all just build cool products and solve problems. So that's it.
Hi, my name is Jake Hitzkis. I work on a music-related blockchain startup company, and I'm a software engineer and an audio engineer. And I really appreciate being here. Love talking with everyone.
Yeah. Well, we have a team member that really loves privacy, so he won't even be up here. But we wanted to talk about our idea after exploring a lot of use cases and thoughts. We wanted to actually solve a problem with an existing client we have, and this was a perfect solution, I think, that solves their problem. And this idea came about with a lot of help from you guys, Ethereum Enterprise, and Provide, and a lot of folks. You guys give us really good advice. And the name we came up with was Donor Baseline. And this idea was around blockchain crowdfunding. So we wanted to go after the next evolution of what GoFundMe might look like. So, secure private anonymous donations that could be proved without actually knowing how much people donated. It's just proof of you donating. So this unlocks a lot of potential for crowdfunding, even verifying if you're a nonprofit, and in different entities, solves a lot of problems, but also that audit and verification of donations. I wanted to pass it on to Oli if you want to talk a little bit of background of the existing client that solves this problem.
So, a protocol is only as useful as the problems it solves. Oh, sorry. So a protocol is only as useful as the problems it solves. So, serendipity, whatever you want to call it, we actually have an enterprise client who actually needs this use case to actually improve upon his application. And when you are creating something like DonorBox, you want to make sure that there is irrevocable proof that an event has occurred and that we're able to verify that event and with verified credentials for that event. So, so actually putting this into a real client use really just inspired our team to work even harder. And thank you to everyone who actually allowed us to even curate the idea even better to actually come to this solution. So because this product is actually going to be live and it's for an actual client, we won't be releasing any code, but just being able to have an enterprise product is it's just blowing our minds away of how we were able to use it. So
Thank you. Can we go to the next slide, please? So yeah, this is just a breakdown of what the platform provides. Secure donations, private donors, being anonymous at the granular level. We have a lot of future ideas that I'll share later, but kind of wanted to just talk about the tech stack. I'll pass it on to Jake.
Absolutely. So the tech stack consists of React.js. For the hosting, we are using Firebase. The APIs we have Provide, and we're also using the PayPal API. And of course, we're using the baseline protocol, which we really enjoyed learning.
So I'll talk about some of the practical applications of what we've developed here. So number one is being able to prove or verify a donation happened without actually knowing how much was donated. So it's just a proof that this payment happened through different payment APIs. So, we're just working with PayPal for this specific use case. In the future, we want to integrate with all payment systems, Stripe, Plaid, any type of centralized payment systems that, existing customers use today. So we're not trying to reinvent the wheel, but just plug and play with existing systems and workflows, but baseline those workflows. So this allows you to have those privacy of those transactions, and there's a permanent secure audit trail with people you want to share it with. So instead of putting everything on a public blockchain and having anybody verify that this happened, you can have granular work groups that you share just that audit trail with. So this is completely different than what we have today in the realm of possibilities of blockchain. And we have the ZK proofs that are essentially storing this verifiable proof that this payment happened. And the cool idea we were coming up with is, okay, so now we have this proof of donation. How do we incentivize people, right, based on what they donated? So this idea of proving different levels of ranges. So if you only donated less than $100, you can mint a specific type of NFT for that person without actually knowing how much they donated. So adding conditional logic on top of the proofs without actually knowing the contents, but rewarding them with NFTs. So you can kind of have a flex on the fact that you donated if you really wanted to. Right. And different types of sponsors can have different tiers of NFTs. So this is a unique idea. We had to even add that incentive layer on top of this system. And these were the work groups that we're thinking about. In our system right now, we have different entities that we thought about. We have the nonprofits, and we have the donors, and we have third parties that can independently verify this information without actually needing to know the information. So, this is just a quick overview of what the relationship or our work groups will look like in our system. And in our roadmap, we have additional payment systems, as we mentioned. We're working mainly with PayPal. We want to integrate Stripe, Plaid, Cash App, even Coinbase. So right now, it's just fiat. Kyle gave us a really good idea to integrate even crypto, so even go a layer deep. So if we want to do crypto payments, just settle those in baseline, crypto USDC transactions, which is also a really great idea and something we might use, provides payment KYC mechanisms for. And also, in the future, we want to baseline all systems. I mean, that's where we want to see happen in the future is PayPal, Stripe, Coinbase are already baselining their systems, so we don't have to, in reality, what we're doing is not what we really want to do in the future. So if we really envision that's the direction we're going, we're essentially taking the first steps, right? And minting these NFTs as receipts, as a proof of donations. We want to leverage using GraphQL APIs to essentially, once we mint the data, we can query it in our front end, use storage to essentially storage our NFTs inside IPFS since it's a lot cheaper. And then there were a cool idea of leaderboard. So based on who's donating how much, you can have a leaderboard just to incentivize, in the system. And DAOs and work groups, system roles were other ideas that we're exploring because this is just an ecosystem and we're essentially onboarding people to a baseline protocol, right? So we have a little demo created that is a YouTube video. Just to give you a rundown of what it looks like. Shad, you want to click on? So this is the platform that we're creating essentially for the client coming in and essentially signing up on an onboard flow. And what we were really spending a lot of time on is essentially integrating the authentication mechanisms. So when people sign up in this flow, filling in their org name, email, username, password, in the back end, we essentially automatically wanted to create them a baseline profile. So the next step would be to, let's say, giving them an option to hit create a baseline account. And on the back end, we already have the data, email, password, username, things that we need to create a baseline account. And once you come in, you can essentially create a campaign. We already had a campaign created just to show about our organization, Minority Programmers, and we created a baseline education fund so anybody can come in and select a specific payment option. So if you click PayPal, it would essentially take you to that website's donation form. So this is just an example of you creating a campaign, donating to a certain user group, and essentially in the back end, keep in mind, nothing's changed. In the front end, it's the same thing you would do, but the magic is happening on the back end. When you're paying this payment right now with your credit card or your PayPal account, what we're essentially doing on the back end is using the PayPal API and storing that JSON data, essentially proofing it, creating a baseline object. And that baseline object is now proof that you just donated. And that proof is what's used to mint an NFT to show you an reward. And if you just fast forward a little bit, this is where we're going through the PayPal API, how we get the JSON data, essentially pushing that JSON data out forward. And as a result of that, we're creating an NFT as a reward for that. Question?
Two questions on that. One thing you said earlier, a baseline ID. Last I checked, there isn't a baseline ID in the spec. Is that a DID or is that a provide work group ID? Is that what that is, or?
Yeah, that's a work group ID. So the
Work group ID,
application-
okay, yeah, so that,
So,
okay, now I understand.
yeah.
And then the other one is, are you proving a range proof of the level or just the fact that you paid, or you know?
Great question. So you want to answer that?
So security comes into play if you put too many ranges into a ZK proof. So initially, we just want to start with one, but as security and everything, yeah.
Above zero, you're proving it's above zero.
Exactly, yes. Or, greater than $50, greater than X value.
Yeah, and that's just a demo. And like I said, we couldn't really share the code just because, proprietary, and we're actually planning on implementing this and taking it to production. And hopefully, when base ledger is actually in mainnet, this is going to be a really exciting use case going forward, solving a real enterprise problem. So thank you guys for listening.
Thanks for the presentation. Baseline.
Testament to what you can do if you don't sleep for 2 days.
Does it work?
All right, up next, we've got the signature written ZKP project. They'll be up here presenting in just a second.
Good. All right. Hello, everybody. My name is Mark Rimza. I'm here with Yoav Baton, Keith Salzman, and Aswini Patro. And fun fact, Keith, Yoav, and I, we all work together at the same company. We work together very closely. And if it looks like I'm shaking up here, it's not because I'm nervous. I'm not afraid of any of you. I'm just really, really cold. That's the only problem here. And I'm wearing a sweatshirt. I don't know if it's because I haven't slept for a couple days or it's just really cold in here. But we're software developers in our day jobs. And, outside of our day jobs, we're aspiring blockchain developers. So we wanted to take this opportunity, join the hackathon as people, who want to, trial by fire, get involved, and see what we can come up with. So what we're bringing to you today is how you can remove third parties from verifying digital signatures by taking a digital signature and basically passing it into a zero-knowledge proof. And what I want to do with you all is go over the use case here. So what we have is, with this capability that we're focused on creating here, we can, like I mentioned, remove the need for third parties to verify your signing. I'm sure we can all imagine what this would look like. Notaries aren't needed anymore. You can verify the signing of documents without them, right? You don't have to pay them. And it's quicker and easier for everybody. Another fun little feature, not entirely necessary, but something that is nice is the fact that you can, sign virtual documents with your signature and not actually reveal what the signature looks like, the actual physical handwriting, just for the purposes of forging, you wouldn't actually reveal it. And we can go over the implementation of this a little bit further into the presentation about what this actually looks like. Part of this implementation as well is making this token, essentially, that we would be creating something that expires, so that if you were to sign something, it isn't, irreparably tied back to your ID in a situation where, you sign something once, you lose it, and then now you can't sign anything ever again. And, beyond this, counterparties are capable of verifying, I already mentioned this, they can verify the signer's proof for a period of time. Ideally, we want this to be something that the signer can set themselves. And, that pretty much covers most of the use case. It's pretty basic, but something that we feel that a lot of companies could use: DocuSign, law firms, rental agencies, real estate, escrow, things like this. And, but there are some limitations. The token expiry period, it would have to be pre-chosen, and you wouldn't be able to alter it after, creating that signature, all of those things, which, could be a problem if you realize that, the period that you want to set it for is not what you originally intended it to be. And this is restricted to digital documents, right? So, it would require the infrastructure. Maybe people don't want to be herded onto, signing everything digitally. It already feels impersonal, and, beyond that, if you were to just take your handwritten signature and turn it into a bunch of data cast away into the ether, that is something that is, in a way impersonal, and, I think that applies to the blockchain space as a whole. It is new and uncomfortable for people, so how do you make it feel like the norm? I guess just swarm them with as many blockchain, assets, facets that they can use as possible, and then it becomes more comfortable. Yeah. So I want to go over the process of how we want to implement this. And what we work through here is, obtaining the image data from a user-created signature. In the front end, what we're using is a canvas. Yoav can go over a little bit more about what that looks like. We're going to generate a hash from the signature. Ideally, we wanted this to be a bitmap, but for now, we're just generating a hash. And then, the step 3 here is running the baseline and provide stack. This is the, the stack that we're going to be using to make this a thing. And what we do once we, run the stack is we can take this hash and pass it into the provide vault, sign the hash. That will allow us to pass this signature into a circuit that we can provision, create this proof. And then from there, we can use this proof, the counterparty can take it and verify this signature, that the signature has taken place specifically with zero knowledge without seeing the signature. So we're going to go over the architecture with you. The broad idea here is we're just going to go through, what this implementation would look like and really the limits of where we were able to implement this. So with that, I'm going to pass it over to Keith. And okay, yeah. So I'm going to cover one more here, and really this is the basic setup for what the work that you would have to do with the provide stack to get this going. Pretty simple stuff. You can find everything in the provide docs. You go through the basic setup in the CLI to run the provide stack, and and all of these actions underneath running the baseline stack apply to the microservices that you're going to be calling to, sign the hash, get it into the zero knowledge proof, etc. And those things are creating a user. You need to authorize it, create an organization, create a work group, and create a vault. All these provide IDs that, go into these microservice calls. And that will essentially give you all the setup that you need to get started by, creating these proofs and then leveraging them. So now I'm going to pass it over to Yoav, and he's going to talk about the front end here.
All right, so for the front aspect of things, we are running on React.js. We have a canvas, and then we are using a SHA 256 hash to hash the, and actually I can switch over to it. If I can get Zoom out of my way. Okay. So here we have kind of a basic demo for it. So we can take in some data, the first name, last name, the date, whatever, right? So we have a canvas here that will allow the user to sign their signature. And then once they submit it, this canvas will turn into a string of data, and then it'll be hashed. And I have here it, in the production version, and of course wouldn't show the user, but for a demonstration, here is our hash. That would then, in future implementation, be passed through to continue on.
And you guys too were able to get the privacy service to work, finally, right? I like it.
Stay tuned. So I will call up Keith to the stage.
All right, so I'm Keith Salzman, already introduced by the great Mark and Yoav. Yoav just went through the UI side of this. Him and Sweeney mainly worked on the UI side with input to the provide stack here. Mark and I mostly work on this, so once they take the, now it's existing as a canvas, and hash that, which in future implementations we'd like a bitmap to be hashed. We're going to take that and we're going to use the provide vault to sign the bitmap hash itself, right? So we're signing this and we're providing we're utilizing the provide vault signing capabilities to sign this, right? And of course, it's going to return that hex encoded 32-bit signature. And next, once we get that, we'll move on to actually provisioning the circuit. So this is something that we want to improve on as well, is creating a custom circuit for our actual what we intend to implement, which is the signature, the digital signature being abstracted. So in this case, we made use of provision circuit from the provide privacy stack. We used a post call. You can see here. We included the name, the identifier. Here, the identifier was used as cubic, right? In actual implementation, we were using the memc to try to get it to work since we lacked that implementation of the custom circuit. Provider narc groth, we ran into a bug where we were initially using BN256, getting a 500 internal server error. Talked with the mystical providing consensus people, mostly Kyle, and got a BN254 to help us out. That worked, that returned the ID, the provision circuit. One of the problems we ran into, you can see here in the right little screenshot grab, is as soon as we sent it, we would see the status of pending setup, and then we would go directly to a get call to, actually see the circuit that was provisioned, and it would immediately fail. We tried numerous things to get a solution for this, and magically after hour 3 or 4, all of these circuits that had been provisioned then immediately, went to actual provision status. So this is something that we're unsure why this happened, right? But it actually solved itself, right? So after provisioning them and waiting, and then they were, reached the status of provision setup, provision, we then made use of the, again, provide privacy, prove the circuit. So in this case, we were using MIMC in practice. We provided a SIG and a hash, or if it was MIMC, it was probably a pre-image and a hash. It looks like these are kind of out of order here. Oh yeah, the screenshots are mixed, right? So we would provide just the witness information to the provide privacy proof circuit, and this would provide us the proof that on our side we would eventually pass to that counterparty. And once they have the proof and then can provide their own witness information and circumstance, then they'd run that next call, which ends up being the verified proof. So we got stuck here. We were able to produce the proof, but anytime we made this call, we were getting a 500 internal server error. So if we were able to kind of hop over that obstacle, we would have been able to really get some kind of implementation working so that we could use the UI, run it, and we could either see in code or by alerts or however the CLI, what information is being passed back or between the two counterparties, what's going on there in the logs. Any questions?
So you're saying that the stack is self-healing? Yeah.
That is exactly what I'm saying.
3 hours, it'll always work.
Hey, I just want to say that I had a good time interacting with you guys all weekend. Thanks for coming.
I think we share the same, yeah. We feel the same.
The signature, or the signing come back was EDDSA, right? Off of the provide vault, is that right? Yeah, was it EDDSA? It was, yeah. There's a reason I'm asking.
Oh, I believe the encoding itself, we were using, was it BN256? The curve?
That's the curve, yeah.
Yeah, the curve is BN256.
It's at DSA.
EDDSA, yeah.
Okay.
So
Any other questions?
real world observation, or actually question is on that. So you are verifying the integrity of the signature. Are you verifying the placement of that signature to whatever document? You're
Anybody
saying,
wanna?
okay.
The main use case here that we're taking care of is the fact that the signature has taken place and that it is tied to a person at a specific, spot in time.
Right.
And, that is a good idea. That's something that we could, look into implementing.
Composability.
Because you want to say that, yes, this signature is good and it was applied to this document, as opposed to, because just having it out there, digitized and everything, it's great, but only when
That's
it
for
is
the
on.
second weekend, I think.
It is.
Yeah, give us another 72 hours. We'll be on that. Yeah, no, that's a very good point. That you could, hash the document, hash the signature, feed that into a zero knowledge proof. I think that would work out.
Right. And will you have put in provisions for notaries, because you've got to have the notarized signatures that they can then not only put their signature, but also their stamp and seal?
Actually, I think the point is that they're avoiding needing that with this method.
Yeah.
Anything else? Yeah, we're good.
Nice project.
Thank you.
Top prize, a new GM car. You guys brought the car, right? For everyone?
All right, up next, we're going to have the Tokenflex project. Let me see if they are ready. They are. Here they come. There you go, Mike. Sure.
Got it, job. Where's my camera? Can you all see? Four. Thank you. All right. I'm gonna need to take this off. Okay, good afternoon. My name is Annette. I am a web designer for NDAO. I'm fairly new to the blockchain community, and I'm eager to be a part of y'all's community, so I would thank you for having me here today. I'd like to introduce my teammate, Aaron Anderson, if you want to say a few words.
Hey there, I'm the Chief Business Development Officer for NDAO, a crypto inheritance solution company.
And we also have our CEO, Ken Hodler. He actually joined us virtually, but he's not here today, so we just want to give him a virtual shout out. So what we like to do is we want to go ahead and talk to you about two things, and they're both pertaining to NFTs, okay? So the first thing that we want to go ahead and do is, well, as we all know, NFTs are, in the digital space, right? But who doesn't love any swag? Everybody loves swag, right? So with the NFTs and the swag, since they're in the digital world, right now there's not really something out there to have your NFTs on the physical, like on a shirt or anything like that. So, and secondly, the second point that I want to go over with you all is, and this is actually the exciting part, which is what if you could get paid residuals for your swag, for sharing your swag on your NFTs on your shirt, right? So in other words, like have your NFT work for you without even having to lift a finger anymore. So what I want to go ahead and present to you is going to be what we call Tokenflex. It's a real world use case technology for NFTs. So currently right now, the problem with NFTs is that the copyrights are very ambiguous. So what we provide for you all is
explicit licenses that are copy licenses that are transferable. Let me give you a quick demo of the website as it stands right now. Okay. Is it a new share? No, it's already up.
okay, cool.
Okay. All right, so this business model has network effects built in through tastemaker incentives. It's a high growth, high scale DeFi integration into consumer goods. It has private and secure logistics management handled by Baseline Protocol. It is a natural moat as the certificate authority in the endpoints are hosted on the Provide stack. We have provable authenticity enabled by using the tree trunk zero knowledge algorithm to match the QR code to the physical item. And we can do that with industrial processes to create printing anomalies or distress marks to the physical item. And let's see. This business is we're calling it style mining. It's a combinatorial growth opportunity for creators and technology partners. And that's what it looks like.
So when you purchase through Tokenflex.xyz, you're going to go ahead and have a custom QR code generated for you. And it's going to be printed on the shirt as well, as you see here. So when somebody scans that QR code, they're going to be taken to Tokenflex.xyz, and they're going to go ahead and be able to order that shirt. Now, since that QR code is linked to the transaction of the originator when they first made it, that person is going to go ahead and get residuals off of each shirt that is purchased through Tokenflex.xyz. So, did you have a question?
Oh, I think I just understood something. So that gorilla or that image is generated by.
That's an ape, John.
Sorry, ape. I'm sorry. I'm tired. The image is generated by kind of a tree trunky, is that right? So that when you scan that and go and get a new shirt, you're getting a child file with its own QR code. Is that the way it works?
That is the way it works. The collection
Okay.
is
So no
licensed
two
by-
shirts are the same, are based on the same exact file, even though they look the same.
The file itself is the entire front space, so it includes white space, it includes the QR. Modifications can be made anywhere on that field, print or manufacturing process, distress marks, etc.
All right. So if I buy that shirt based on this shirt, the owner of this shirt will get some royalties, and we have related shirts, but they're not the same exact file.
Right, they will have
Got it.
microscopic differences.
So now, while we understand that there are many ways that you can, copy paste an image and then print it on a shirt, that's not just what Tokenflex is about. It's about the residuals, about getting the creator residuals off of their original artwork. So that's the one thing that makes Tokenflex stand out amongst other markets that are going to be printing the NFTs only. What we want to do is, give back to the creator of the NFT, so that way they can start building maybe their own brand, because they're going to have so many different NFTs that are going to have about. But the originator or the creator is who we want to go ahead and give back to and make sure that they're taken care of by getting the residuals off of each shirt. So that is Tokenflex. Anybody have any questions on it?
I think it's a really cool idea, first of all. For the barcode that you scan, is it always placed right there on the shirt? I'm asking actually just because maybe if somebody tucks their shirt in, or, is it going to be on the sleeve? Have you guys thought about the placement of the barcode just from, if I was wearing that shirt, I'd probably tuck it in and then nobody would see the barcode.
Yeah, I'm glad you brought that up, because my idea was to put it on the sleeve, so that way it's always visible. But it's something that is definitely optional. You can definitely move it around anywhere you would like, especially if you're the type of person that always tucks in their shirt exactly. So I would prefer it on the sleeve if it were somebody like me. Yeah, definitely.
Could I just get a barcode tat with that? No.
My question is, what's not clear to me is what's built so far of this process. Okay, you're about to go into that, great.
Yeah, when we came here, we wanted to be able to have a complete business product that we could come up here and purchase on stage at the end of the hackathon. As we were working with Provide and Baseline and Tree Trunk, we got to see that there is more going on here than just print-on-demand NFTs out of your wallet. There's an entirely new way to bring DeFi and NFT derivatives to the physical space. So we went down there's a lot of code that is in the back of the repo that is not up here. Some things include, there's a contract there that handles the revenue disbursement and tracking that and allowing the different parties to go and pull the accrued revenues. Stuff like that is in there. Yes, ma'am.
NFTs. People who create NFTs, do they want to put them on shirts? Do you guys research that? I mean, is that something that people want to do?
So that's a great question. At Met Gala recently, we had probably 3 or 4 people who were wearing their CryptoPunks as lapel pins. We've got NBA players putting their profile picture NFTs on Twitter. Twitter has even integrated with Ethereum to validate NFTs in people's profile pictures.
Yeah, it's easy enough. Yeah, it's easy enough to put the image of the thing you bought on anything you like, but to be able to say, yeah, this is actually printed from the file that I own would be kind of interesting. Yeah, I get that.
Right, and we can do that with the technology stack that Provide gives us. So each of those parts of the process can be tracked. What's what I'm looking for? Where you own it, it's private data, it's proprietary. That's the word I was looking for.
There's a company, good friends with from years ago, Chronicled, that started, so it's funny how those themes come back around. Do you remember Chronicled? They were effectively doing that with tennis shoes in sort of the first wave of, they weren't really doing it NFT style, but they were using the buzzword back then was blockchain, not NFTs. And so they were basically blockchaining your tennis, you know, like a designer shoes, and they were putting a branding or a mark on that shoe. They were doing that. Now they've moved on to like medical at this point, but yeah, you might look up the
business
Chronicled.
Too early.
Yeah, they were early.
Yeah, this is the right time. The technology is just coming online, and it's about to be mature here in the next 2 quarters. And whenever the technology is mature, this business model is likely to set the pace, the tone for how people show off their swag, how they monetize their style, how they tokenize forms of capital that aren't just financial or material. They're able to tokenize culture, tokenize.
This is a great idea.
Yep.
It is a very great idea because, you know, a lot of times when you start to say, well, you have knockoffs and counterfeits, something that is not the genuine article, and this is yet another way of sitting here proving that, you know, yes, this is real. So.
Great idea, and I'm personally very interested to see how it develops. And it's also interesting because it uses our stack as well as the tree trunk algo. So very cool.
Thank you very much.
So we have just one more left, I believe.
All right, can everyone hear me? Cool. So we decided to tackle the base ledger entropy beacon bounty. And so I don't know if you guys remember, but the idea was to be able to pull in some verifiable randomness into base ledger core. And to do that, we leveraged the Chainlink smart contract. And so I'll just recap quickly like what the workflow looked like. So there's a smart contract that we use from Chainlink. It's the random number consumer, and so we actually first step was CK stuff. Can we actually like deploy this on Remix? This is our first time really like in working like with Solidity Remix in the smart contract space. So we're like, all right, let's see if we can deploy this, get it to run, fund it with some link, kind of dabble around. It's a pretty simple contract. You can request a random number. This talks to the link VRF contract, and then there's a callback that returns this random result. So like, then you can just call it using like just a regular call, and you get this randomness. And so that was the first step. Let's see if we can actually go ahead, deploy this, run it, get some verifiable randomness. And then the next step is like, how do we actually get that in the base ledger core? So we started like diving deep, into, probably not that. So we started like just like diving deep into the base ledger core repository. There was some hints on like where to start. So Kyle had some like template functions to start off with. And so we don't have like a formal presentation, so I'm just going to go through some of the code we did. But the first step was how do we call the smart contract from the base ledger core project? Yeah.
Yeah, there you go.
A little bit better. Okay, so there's two methods that we played around with. The first one was resolve beacon entropy, and this one actually gets called. So just to back up, like base ledger is using Tendermint as its consensus engine, which is like Byzantine fault tolerant consensus. This was the first time using like Tendermint as well, or like learning about it. So it has this ABCI, which is how Tendermint talks to the application. And so there's these methods like deliver TX, commit, and block. And so the idea was when the block ends, let's see if we can get a validator to call this resolve random beacon entropy and then shove it in the block header. I actually think this needs to happen not in end block, but in begin block, because that's the only time you actually have access to the header. And so to be able to stuff stuff in the header, you need to have access to that. And so I think this is where that method would be called, but I don't know, maybe we can figure that out later. But for now, it's being called an end block. And so, so the end block's called, the validator then wants to grab this resolve random entropy, goes into this function. The way that the code's set up is that there's a query.go file, which is how you want to query out to anything. There's only two right now. It's either, sorry, two paths. It's either baseline entropy fetch or P2P filter address. This is like just to like ping your other peers. So this can definitely be extended, but we use this path. And this is as far as we got to. So we used nchain to actually execute the contract. And we didn't get a full response yet because we had trouble with like deploying like a network in nchain. And yeah, so it's just kind of like analysis of what we did. Didn't really get anywhere, but it was a cool project. If you have anything else to say.
That's good.
Yeah. It was his first time learning Go, so that was cool.
You guys learned Go over the weekend? That's okay.
I did. Yeah.
All right.
This
Yeah.
is my first time looking at Go.
We're, that's going to definitely earn special mention. Question about, so the idea here is that if you really, really, really need to be super duper sure about your random number, this is where you would go, right? Because there's a little bit of overhead on this, right? But you know, there are use cases where just pseudo-randomness isn't gonna do it, and you want to be damn sure, right? And that would be the, kind of the pitch for this. And where do you see this going in? Is this like a feature that would go into the ride stack, or is it open sourced, or is it
Base
a
Ledger.
new feature for Link? Huh?
Base Ledger.
For Base Ledger, so you're gonna put this into Base Ledger?
This is Base Ledger core.
Nice.
Looks like it's part of the core code, I guess. So I'm not exactly sure how it's going to be used, but we just thought it was a cool problem.
The use for it is for multi-party computation ceremonies and adding entropy to those ceremonies so that you don't need any honest parties at all. They can all be dishonest, and you can still have a successfully and a trustworthy multi-party.
So I could use that in tree trunk, and right when I don't, right now they got to trust us to generate entropy or
You would generate it,
Pull it right
and then
off
you
the
would
base
augment it. You would augment your entropy with this entropy.
Ooh, I like that. Okay, cool. Thanks.
Yeah, so I think like the next steps are working with Kyle, because he had some stuff he was going to add to make it easier to actually call the contracts, because it's not as easy as just like deploying to Rinkeby. You actually have to wrap them in Nchain, and Nchain returns this ID, and then you use that ID to talk to the contracts. So I think that's really our only blocker. And I think we'll try to submit a PR once that's done and see if we can integrate it into Base Ledger Core.
Yeah. Welcome to the community, and thanks for presenting.
Yeah, thanks, guys.
Absolutely.
Yeah, that was the last one, right?
That was it.
Before we lose the teams, well, first of all, applause, please. So, thank you all the teams from the whole Base Ledger community. I'm sure that anybody that's not watching on screen today is going to be watching these videos. I mean, they watch my dumb videos every week, so this stuff is actually better content in my view. So I think that you guys will be celebrated and remembered for this work, and we're going to judge and see if we can do better than that. But I just want to remind everybody that you all deserve to be core devs, unless you don't want to be. And if you don't want to be, you're going to be core devs anyway. So please do a pull request, sign up on baseline-protocol.org and go to the sign up and click the active community, and then and yes, that's too many clicks, sorry about that. But then click on the core devs membership, and we will be reaching out to you to get you into the meetings. It's going to be super fun and super impactful, and not like a big hit on your time. So we want your insights, and now you guys are some of the most qualified people to help guide the future of the project. And I bet you've got like 100 baseline improvement proposals to make right from this hackathon, and we want every single one of them. So thank you.
Indeed. Judges, let's deliberate over here for a moment.
We're here in a secret meeting. I'll keep a live mic so you can hear it all.
Hello. Do you guys, John, you're in the way of the camera. John, please step to the side of the camera. Thank you. Okay. Yeah. Jack. Zach. Alex. All right, whatever. Okay. We're not live. We're not live. We're live? Not live. I got it. Check. Are we ready? Yeah. Gotta wait still. Everyone stay excited. But we want it now. And why? Why? Why?
I'll warm with the crowd. This doesn't need to be on camera. So everybody, we took a vote at the technical steering committee of the baseline protocol. As you may know, the Ethereum Foundation it gave us a very generous grant of $100,000 this year to spend on baseline improvement projects. And we have spent all of that money, except we reserved some for this hackathon. And it's a larger number than you may have been aware of. And so Kyle's going to hand out the awards. We did a really fun voting. We all Rochambeaued on each of the factors, and it worked great, just like a good sprint review. So the TSC will vote on the distribution after Kyle awards them, and then we will get those monies to you in the month of October. Sonal and I will be responsible for that to you. And with that, you good?
Thanks, John. Are we good, David?
I'm just going to do it.
All right. So we do have a winner of EthAtlanta 2021. It is that team from General Motors and Digisig. You guys have won EthAtlanta 2021. You guys will receive an extra $1,000 bonus on top of what everyone will walk away from. Every single project is walking away with $2,000. Every single participant is walking away with $2,000. Thank you for coming to EthAtlanta. This was a lot of fun, and yeah, we'll probably do it again next year. Cheers.